Hi everyone and welcome to chapter 1. Before explaining how desalination works, first we need to explain the reasons why we need it. The world population has been increasing considerably in the last 2 centuries. In 2018, the world population was 7.633 billion. Predictions show that by 2100, the Earth's population could surpass 11 billion. This population growth is due to many factors, including reduced mortality rates thanks to the improvement of medical services and also the improvement of average quality of life. Some countries like China and India have more than 1 billion population each alone. Data about world population growth shows that almost all of this growth happened just very recently. Historical demographers estimate that around the year 1800s, the world population was only around 1 billion people. The population grew very slowly over this long time from 10,000 BCE to 1700s by 0.05% annually. After 1800s, this changed fundamentally. The world's population was around 1 billion in the year 1800s and is now around 8 billion, 8 times larger. The global population growth rate, however, peaked long ago. The chart shows that the global population growth rate peaked in 1962 and 1963 with an annual growth rate of 2.2%. But since then, the world population growth rate has halved. For the first half century, we have lived in a world in which the population growth rate has been declining. The UN projects that this decline will continue in the coming decades. World population, however, as illustrated in green in the chart, will keep rising in the upcoming years, even though the annual growth rate is declining. This growth, however, comes with the challenge of providing enough safe water for everyone and for all types of uses. Water use applications are very diverse, but they can be divided into 3 major types: domestic, industrial, and agricultural. Domestic use amounts to only 8% of total consumption. Industrial use consumes 22% of total water, and the biggest part goes to agricultural sector with 70%. Domestic use of water amounts to only 8% of total use. It includes indoor and outdoor household purposes such as drinking, hygiene, cooking, bathing, washing, and gardening. The human body can survive without water. In fact, the human body weight is made of 50 to 60% of water. Scientists report that adequate average daily fluid intake is 3.7 liters for men and 2.7 liters for women, with fluid including water, beverages, and food. An average consumer needs at least 50 liters per day for a decent life. In developed countries, consumers can use up to 250 liters per day, such as the USA. And of course, water has to be clean and safe to consume, so you can imagine the challenge of providing billions every day with safe and enough water. Water is not needed for domestic use only. It is also important for industry. In fact, industrial use of water is estimated at 22% of total water use. A lot of industries, if not all industries, need water to function. It can be used for cooling, petroleum, refineries, textiles, mining, computers, and the list goes on. Large amounts are particularly needed in industries of food, paper, and chemicals, and you'll be surprised to find out how much water is required for industry. We use too much water in industry that the world economy could collapse in case there is not enough water to answer to industry needs. One example of sector that requires huge amounts of water is the textile industry. Producing one cotton t-shirt and one pair of cotton pants would require around 200,000 liters of water, which is certainly a lot. Agriculture is the biggest consumer of water. It consumes 70% of total world water production. We simply can't grow crops or any kind of vegetables or fruits without water. Without water resources, there is no food security. Typical use of water in agriculture includes irrigation, sustaining livestock, and mixing with pesticides and fertilizers powders. Farming meat and poultry are particularly water intensive. In fact, producing 1 kilogram of bovine meat requires more than 15,500 liters of water, while producing 1 kilogram of chicken meat requires 4,325 liters of water. Irrigation also consumes a lot of water. Producing 1 kilogram of nuts requires more than 9,000 liters of water, while farming 1 kilogram of cereals requires 1,644 liters of water. Fruits and vegetables require both much less water compared to meats and cereals. They require respectively 962 and 322 liters of water for every kilogram produced. And that's why you hear that eating less meat and more vegetables is good for the environment, because in fact it is true. We need less water for vegetables and fruits than we need water for meat. But with so much demand for water, do we have enough water on Earth for everyone? Planet Earth, also called Blue Planet, is called so because 70% of its surface is covered with water from oceans. Water on Earth can also be found in underground aquifers, icebergs, lakes, rivers, and vapor. In fact, water never sits still. It follows a continuous cycle of evaporation from the Earth's surface, condensation in the atmosphere as rain and snow, and then precipitation. You might think that we have a lot of water, which is true, but how much of it is usable? Studies show that the biggest part of water on Earth is in the oceans. They constitute 96.5% of total water on Earth. But unfortunately, ocean water is not drinkable or usable for agriculture and most industries. The proportion of fresh water on Earth is only 2.5% of total Earth water, which in turn contains 69% of glaciers and ice caps, difficult to use as drinkable water. The other 31% is made of groundwater, surface water, and other freshwater resources, and can be relied on to produce drinking water using conventional water treatment technologies. However, with the increasing world demand for water for domestic, agricultural, and industrial use, the small freshwater proportion we have is not enough anymore. Studies show that the world water consumption has been increasing year after year. Between 1900s and 2000, Asia was the continent with the highest water consumption evolution. Its water consumption was multiplied by 4. Also during the period, the world water consumption was multiplied by 8. This is mainly due to the world population increasing, socio-economical development, changing consumption patterns, and increasing demand for agriculture and industry. To make things even worse, there is the challenge of water quality degradation. Water supply becomes harder when the small proportion of fresh water we have in rivers, lakes, and groundwaters is at risk of pollution. Water quality in water resources degrades easily in the presence of harmful substances and can become toxic to humans and the environment. Unsafe water can cause the transmission of infectious diseases to humans such as cholera, typhoid fever, diarrhea, and kidney problems. Polluted water can also harm fish, marine mammals, and sea turtles and disturb mating rituals. Water pollution types include pesticide pollution from irrigation, nutrient pollution, plastic pollution, sewage pollution, oil pollution, and factories pollution. Pollution endangers our water resources and makes it complicated and costly to produce drinking water. Another challenge we have witnessed in recent years is climate change. Climate change is the talk of the hour. It is due to many factors, including excess of use of fossil fuels such as coal, gas, and oil. Deforestation, because of which we don't have enough trees to absorb carbon dioxide, and increasing intensive agriculture which emits greenhouse gases. Climate change impacts water resources in many ways. by trapping sun energy, causing oceans to absorb more heat and have the temperature increase. It causes iceberg to melt and rises in seawater levels. Climate change disturbs precipitations and snow patterns, which is already confirmed in many regions in the world, witnessing unregistered patterns of seasons. Climate change also increases the frequency of floods and droughts, which brings devastating consequences. The combination of all these factors and other factors has led to a difficult water situation. Because when the ratio of water withdrawal to water resources is very high, then we have a problem. And since renewable internal freshwater resources are limited, at risk of pollution and declining in many countries, and since global water demand keeps increasing, water stress and the risk of water scarcity are now an inevitable concern. Predictions show that by 2040, North Africa, Middle East, Asia, and the USA will witness extremely high and high water stress. These circumstances have led to the rise of desalination. In fact, this dire situation has left us with no option other than relying on ocean water resources to transform it into drinking water, which is desalination. And given how oceans are saline, they can't be used directly for domestic, agricultural, or industrial use, except in few cases, and that's why we need desalination to remove salts from water and make it drinkable. Oceans provide an unlimited source of water to transform it into drinkable water, and the processes of desalination are the key to make it happen. And although desalination is energy intensive and only doable for coastal countries, it has saved many cities around the world from droughts, and many countries rely on it as a primary source for drinking water. In the next chapter, we will talk about the history of desalination and how much it's being used worldwide to solve the water stress problem. Thank you.